Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 7 of the CSEC Maths January 2013 video solution, and this question 7 gives us a grouped frequency distribution table for the scores obtained by 100 students in a competition. So these are the scores, these are the class midpoints, this is a group frequency distribution table. So these are the classes, 1, 2, 3, 4, 5, 6 classes, and these are the midpoint values. The table is not completed. These are the frequencies, meaning there are 8 students for this class or this group, 13 students for this second group, and so on. And these are the f multiplied by x, the frequency multiplied by a midpoint value. So here 8 multiplied by 4.5 is 36, and 13 multiplied by 14.5 is 188.5. And again here the column is not completed. Now the first part wants us to state the modal class. Now the modal class is the class which has the highest frequency. And so if we look in this frequency column, the highest frequency is 25. And therefore the class that corresponds to this highest frequency of 25 is this class. And therefore the modal class is the 20 to 29 class. And so that is the answer. The modal class is the class with the highest frequency. It is the 20 to 29 class. Part 2 wants us to determine class interval for 19.4. A student who scored 19.4, we want to say which class interval 19.4, a score of 19.4 would be placed. And a 19.4 would approximate to 19, and a score of 19 will be found in this group, 10 to 19. In fact, this group, the second group, would take boundary values from 9.5 up to below 19.5. The boundary values for this group are 9.5 and 19.5. And so a score of 19.4 will be placed in this second group, 10 to 19. And so the answer for this is 10 to 19. A score of 19.4 will be placed in the 10 to 19 group. Part 3 wants us to complete the table, and therefore we need to complete this midpoint column and also complete this fx, f multiplied by x column. Now, just to show how the calculation is done for midpoint, the definition for calculating the midpoint, for example, in the 20 to 29 group, would be to take the average of the boundary values. That's by definition. By definition, midpoint is equal to the average of the boundary values of the group. And the boundary values of this group would be 19.5 and 29.5. And we have to divide that sum by 2 to get the average. And so the midpoint value for this group would be 24.5. But alternatively, we could calculate the midpoint using the average of the limit values, because you can see the 0.5 that is removed from this 29.5 to give us 29 here is added to this 19.5 to give us 20 here. And so the average of the limit values also would give us the midpoint value. The fact is that the midpoint value is halfway between the boundary values and also halfway between the limit values. The limit values in this group are 20 and 29. Lower limit is 20, upper limit is 29, and the midpoint will be halfway between these two limit values, and also the midpoint will be halfway between the boundary values of 19.5 and 29.5. And so in any case, the midpoint for this group is 24.5. We also could observe that the difference between consecutive midpoint values is 10. So we add 10 to 4.5 to get 14.5, and so we would have to add the same 10, and this is because the classes are all of the same dimensions: 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. The classes are evenly distributed, and therefore the midpoint values would also be evenly distributed. And since the difference between these first two is 10, it means that the difference between the subsequent values would also be 10. And so to get the third value, we could simply have added 10 to this 14.5 to get the same 24.5. Therefore, to get the remaining values, we simply need to add 10 to this 24.5, and that would be 34.5. Add 10 again, and here we would have 44.5. And then when we add 10 to 44.5, the result here is 54.5. And so these are the midpoint values. And now to complete this column, we simply multiply the frequency value by the midpoint value. And so the value for this cell will be obtained by multiplying 25 by 24.5, and the result is this value, 612.5. and then for here we multiply 22 by 34.5, that result is 759, and then we will multiply 20 by 44.5 for this cell, which is 890, and then multiply 12 by 54.5 to get this value of 654, and then the total here would be the sum of these values, and that total is 3140, and represents an estimate of the total score by the 100 students. This 3140 is an estimate of the total score of the 100 students, because for example here this 36 represents an estimate of the total score of the 8 students in this group, and the estimation is made by assuming that all 8 students in this group had a score of 4.5. And so we have now completed the table. Part 2 now wants us to calculate the mean score from this information, and as I said, this 3140 is an estimate of the total score by the 100 students, and so the mean score is calculated by taking the sum of this column fx, that's the sum of f times x, divided by the sum of the frequency, which is the total number of students in the survey. And so the mean bar x is calculated using this formula: the sum of f times x, which is this value, divided by the sum of f, the total frequency, meaning the total of students in the survey, which is 100. And that calculation becomes 3140 divided by 100, which simplifies to 31.4, and therefore the mean score is 31.4. Let's move down now to part C of this question. Now what we have so far is that the mean score is 31.4, and we have the completed table. Now part C is asking us for a reason why the mean, as we have calculated here, is an estimate of the true mean. That is, why is this mean score 31.4 only an estimate of the true mean? And this is the reason. In this calculation, it was assumed that each student in a class interval had a score equal to the midpoint value of that class interval. And for example, it was assumed that each of the 8 students in the 0 to 9 class interval had a score of 4.5, and this is it. In trying to determine the total score of the 100 students, it was assumed that, for example, in this group, each of the 8 students from this group had a score of 4.5, but that is not necessarily the case. In this second group, it was assumed that each of the 13 students from this group had a score of 14.5, and so in all the cases the midpoint of the group was used to represent the entire group, to the extent that it was assumed that all the students in a group had a score equal to the midpoint of that group. And this is why this mean that was calculated using these assumptions is not the true mean but only an estimate of the true mean, because the midpoint values of the group were used to represent the entire group. And so 31.4 is only an estimate of the true mean. Let's move down now to part D. Now in part D, we are told that students with a score of at least 40 points will advance to the next round of the competition, and we are required to calculate the probability that a randomly selected student will qualify to the next round. And as I said, to qualify to the next round, a student would have to score at least 40 points. That means 40 points or more. So what we need is to find the number of students who scored 40 points or more. And these two groups are the groups of students who scored 40 points or more. And the total number of students from these two groups would be 20 and 12. 20 plus 12. So that's 32 students. And so 32 students scored 40 points or more, at least 40 points. And so the probability of selecting one of these 32 students from the 100 students in the competition would be 32 divided by 100, and this is it. The probability of randomly selecting a student who scored 40 or more points, that is greater than or equal to 40 points, would be equal to 32 students, because 32 students scored 40 or more points out of the 100, and so that probability is 32 divided by 100, which is 0.32, and that's the answer for part D. And so that's a completion of this question 7, and we'll do question 8 in our next video. Alright, see you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.